For today's lesson, we're going to be talking about Ohm's law, which relates three of the variables you practiced in lab with: current, voltage, and resistance. So Ohm's law kind of relates these three variables: current, the amount of electricity or charge flowing through our circuit. Resistance is something that slows down or uses that electricity, like a light bulb. And then voltage is the power kind of supplied by the battery or an outlet if we're talking about AC current. So current is symboled with the letter I, and it means the rate of flow of charge that passes through space. So how much charge is flowing through the wire is your current. So symbol is I, but is measured in the unit called amperes, or amps for short, which has a unit of A for amps. So symbol in the equation is I, but it's measured in amps, which have a unit symbol of A. Voltage then is the push that moves the charge through the circuit. So symbol is a V for voltage, and it's measured in the unit volts, also with a V. So it's sometimes called electrical potential. And all it means is that there needs to be a difference in charge of our voltage in our circuit in order for charges to move through it. So that's why a battery has a positive and a negative end, or your outlet has two different types of prongs. And so the electrical current or charge gets pushed through, so the negative charges get pushed away from the positive and towards the negative. Reverse that. So they get pushed towards the positive and repelled from the negative. And that's what moves the charge or the current through that circuit. So without a potential difference or without voltage, our charge would not flow. So the most common thing we're going to be using to provide that voltage is a battery. It's like a 9-volt battery, provides 9 volts of push. Or your AA or AAA provide that 1.5 volts of charge. The other variable in our circuit is the resistance. So resistance literally means the tendency to slow down the flow of electrons. So it's resisting the flow. So it slows our electrons down. Now, any device like a light bulb or something you plug into your outlets causes some resistance. Wires cause resistance, or you can actually use resistors to slow down that flow, because if our current is flowing too fast, a lot of times we can overheat our circuits. So we plug in resistors, things that look like this in the picture there, to slow down that flow of electrons. So the symbol for resistance is R in our equation, and its units are ohms, which is the Greek letter omega. Kind of looks like a upside down U. And so how do we determine the resistance of material? So it depends on kind of three things that you investigated in lab. One was length. So longer wires are going to have more resistance just because it has to flow through more material. So it's going to slow it down. It's going to cause the wire to heat up a little bit. So the longer you have to move your current through a longer circuit, it's going to have more resistance to it. Also, the area of the circuit. So thinner wires provide more resistance because you're forcing charges to go through a smaller area. So it slows them down a little bit more. So thicker wire has less resistance, thinner wire has more resistance. And then the resistivity, which is just a measure of the type of material. So certain materials provide more resistance than others. So like most metals provide pretty low resistivity, but there are some metals that provide higher. So just the type of metal. So the length, the area, and then the type of material that you're using all determine the resistance of it. So resistivity, you can kind of see the different materials here. So the lower the number, the easier it is for the current to flow through it, so the less resistance it would feel. So silver, really good, copper, gold, aluminum, but we don't use silver, even though it's the best one, just because it costs a lot more. So copper gives us a good amount of efficiency, less resistance, but it's a lot cheaper. So here's kind of a cartoon that kind of demonstrates these three variables. So remember, current is your amps moving through it, so what gets pushed through the circuit. Voltage is what's doing that pushing or moving the charges through. And then your resistance measured in ohms is what slows down your current. So we know current and voltage from our lab is a direct relationship. So as current increases, voltage increases. So if we want more charge to flow through our circuit, we need to have more volts pushing it through. But current and resistance are the opposite. So the higher the resistance, the slower your current moves through it, your charges move through it. So it's an inverse relationship. So they do the opposite thing. So as resistance increases, current is going to decrease, right? Resistance is slowing something down. So if we have a high resistance, we're really slowing down those charges from moving through. So that we can see that relationship in the equation here. So I standing for current. Remember, measured in amps. So you'd see an A next to that number. V standing for voltage. Measured in volts, that's an easy one to remember. And R is resistance. Measured in ohms. So our omega for our symbol. So current equals voltage divided by resistance. Now we can rearrange this equation to solve for different variables. So if we wanted to get V by itself, we would multiply it by R. So voltage is current times resistance. And if we wanted to get R by itself, we would just use this equation divided by I. So resistance would equal voltage over current. So we can use this equation to find either three variables. Okay, let's try this example. So what happens to the current in a circuit if we have 20 ohms of resistor is removed and replaced by a 30 ohm resistor? So if we're going from 20 to 30, we're increasing our resistance. So remember, current and resistance are the opposite or inverse. So that means our current should decrease. It should get slower. Question 2. So headlights of a car are powered by a 12-volt battery. What is the resistance of the headlights if we draw a 3 amps of current? So we're going to use our equation, I equals V over R, and we're trying to find our resistance, or R. So I'm going to plug my variables into my equation. So I have 3 amps for current. My voltage is 12, and I need to get R by itself. So I'm first going to multiply R to get it to the top. So I have R times 3 equals 12. And then my last step, I'm going to divide both sides by 3 to get my answer. So my resistance should be 12 divided by 3, which you can do that one in your head. You should get 4 ohms of resistance. My ohm's a little off there. And let's try one more. So an electric heater works by passing 115 amps through a coiled metal wire, making it red hot. If the resistance of the wire is 1.5 ohms, what voltage must be applied to it? So I'm going to use my equation, I equals V over R. And I'm going to be solving this time for voltage. So my current is 115. My volts I do not know. And my resistance is 1.5. So to get V by itself, I would multiply both sides together. So 1.5 times 115. And I get 172.5 volts for my answer. Now you're going to practice this a little bit more on your worksheet using this equation.